Hi, we're going to use the polar area sweep demonstrations project from the Wolfram website to figure out the limits of integration for the area integral of this curve right here. Right, this curve is 3 sine 3 theta, and it gives you a 3-leaved rows, as they say, and we're trying to figure out the area of, say, one of these leaves. To do that, let me take the slider that controls the theta angle, and do you notice as I'm going backwards, the theta goes back to 0 and the area is 0. So now I move the theta back forward, and I will be able to sweep out the area. So let me stop, say at around 0.256 pi, so that's about pi over 4. So from theta equals 0 to theta equals pi over 4, you've swept out this much area. So when you set up your limits of integrals in polar coordinates, you would have your limits of integration go from theta equals 0 to theta equals pi over 4 to compute this area. Now, of course, we're looking for the area of the entire leaf. So let me just keep moving the theta, and I'm getting very close to hitting the origin. I overshot it, so let me move backwards. So I'm roughly at the origin, which should be at pi over 3. If I'm at pi over 3, I get sine of 3 pi over 3, which is sine of pi, which is 0. So I should end up back at r equals 0 at pi over 3. And sure enough, this is approximately pi over 3 right here. Sine of theta of pi over 3 times 3 is sine of pi, which is 0, and 0.33 pi is approximately pi over 3. So now if I set my limits of integration from 0 to pi over 3, I can calculate the area that's been shaded. And I just have to multiply it by 3, because by symmetry I can get the area of the entire figure.